his postdoctoral research work in cooperative networks in 2018. Sir has almost spent a decade in research, instructing, counseling, and down-to-earth application movement. His exploration skills covers image processing, cooperative networks, electromagnetic fields, electronic devices, wireless networks, and medical electronics. He has taken an interest and presented 3 papers in national level technical symposiums, 9 research papers in national level conferences, 31 research papers in international conferences, 60 research papers in refereed and index international journals in the field of embedded systems, networking, digital image processing, network security, and VLSI. He has 3 international patents and 5 national patents to his credit, out of which 4 had been granted and 4 had been published. He has attended 45 technical seminars, training courses, faculty development programs, and has contributed with 25 dissertations, theses, reports, and publication houses. He is the recipient of 15 honors and Best Faculty Awards, including Best Knowledge Exchange Transfer Initiative of the year 2017, Engineering Leadership Award, Young Scientist Award 2017, Sir James Prescott Jewell Award, Outstanding Digital Innovator Award 2017, 2018 Albert Nelson Marquis Lifetime Achievement Award, Exemplary Information and Communication Engineer Award, and Greenpeace Award 2017 for his excellence in engineering education. At present, he is a member of 140 professional and social welfare bodies over the globe. He has organized nearly 23 self-supporting national level technical symposiums, conferences, and workshops. Currently, he is working in network security, VLSI, biotechnology, management and architecture, and he is a technical advisory board member of nearly 90 international and national level conferences over the globe. He is chosen as an elected fellow from ISECE Malaysia and a life member of ISTE India. We welcome you, sir. Moving ahead to our next presentation for ID. Just a moment, please.
Ma'am, before beginning the session, I would like to ask you, how many papers do we have for the session?
So for this session, we have 10 papers that will go till around 12. And every author will speak for about 8 to 10 minutes, followed by a Q&A session.
Yeah, a very good.
I request all the authors who have joined to have your presentations precise for about 5 to 8 minutes, so that Q&A session can be run and we can have our presentations in 15 minutes time. Thank you.
Okay, ma'am. Thank you so much. A very good morning to one and all. Myself, Urvashi Rahul Saxena, and I'm here to give my presentation on systematic review on recommendation systems to select trustworthy cloud services and ensure data integrity for ICTACS 2022. We all know that in due course of time, specifically in the pandemic era, there has been an accelerated growth for cloud service recommendations, and all of us are supported by everyday life, specifically in the famous e-commerce websites, Amazon and Flipkart also, for suitable recommendations so that we have genuine and trustworthy recommendations for selection of cloud service providers. Right now, below are the few examples. For example, Amazon uses S3, that is simple storage service for offering durable services. Cloud, we all in daily life use cloud storage to provide durable and highly available object storage. Microsoft Azure storage, it provides a durable storage and economical as well for small and big data. The major contributions of my study in this paper focus on different categorizations of recommendation systems that are existing today, their advantages, their disadvantages, an interrelationship and amalgamation between the recommendation and trust, and eventually I've performed a SWOT analysis on the recommendation system on parameters like trust, security, interoperability, etc. So recommendation systems can be categorized into collaborative filtering, which can be user-based and service-based, and content-based, hybrid, knowledge-based, and graph-based representation. Graph-based representation is done to build the trust-based network systems, and the basic and most popular recommendation systems are collaborative recommendation systems. They work on the concept that if we have user 1 and user 2, so what has been identified is similarity between these two users, and when we have similarity relationship, maybe using the Pearson's coefficient correlation, accordingly the services are recommended. So the advantage is that we don't need to be concerned about U3 and U4. That means other users in the list. But the basic drawback is cold start problem. That means cold start and data sparsity problem. That means either one, we have limited amount of data available, and two, if we have lower similarity users availability, then maybe we're not able to recommend the genuine service. Then content-based recommendation systems. These recommendation systems are based on the past historical preferences of a particular user. For example, if we visit a particular website and we have a track record of using a certain kind of items, so we prepare a user and item matrix, and if we have a specific rating X for a particular item, then based on this historical data only recommendation is being done. But until unless we train the particular system, we are not able to sort of give recommendations. So eventually an hybrid recommendation system was formulated, which is an amalgamation of collaborative filtering provide a solution for cold start and data sparsity problem. And apart from that, we have graph based system and knowledge based system as well, and still a lot of research has been going on in that domain. Popularly, the domains for service delivery is B2B, that is business to business, which is prominently used by the famous e-commerce sites like Amazon and Flipkart, wherein the request for the service as well as the reply for that particular service is delivered to the service provider itself. Whereas in business to customer e-commerce application domain service, the request is generated from the service users end, and the database is stored to the service providers end. So it's a client server relationship over here from service user to service provider. In our study, we actually follow this particular flow chart, wherein if we have a user can either be a registered user or a new user, and service can also be an already existing service or a new service. So if an existing user attempts successfully login, then either you can rate an already existing service, or if a particular registered user wants to initiate for a request for a new service, that service may be related to infrastructure or platform, or perhaps maybe software as a service, then based on the ratings and the rankings generated, maybe using collaborative filtering or content based filtering or hybrid based filtering, the recommendation is being done. And based on the feedback and the responses, the service is either recommended or it is not recommended, and the data set is updated accordingly. And if it yes, even if it is a new service or it is a registered user, you can attempt and you can recommend the service. So this is the actual process flow that this particular systematic review has emphasized on. And my basic objective was the SWOT analysis for the recommendation system. The strength is that since every day we have huge amount of request for cloud services, so it becomes a challenge for us to provide genuine and authentic, trustworthy cloud services. That is definitely the need of the hour. That is a challenge, perhaps, and it is also one of the biggest strength that there is a constant need and urge for recommended services. One of the basic weaknesses is if we do not have sufficient amount of recommendations, or perhaps if we have redundant recommendations, then trust management system functionality can be affected. So it is one of the weaknesses that can also be taken as a challenge, and we need to propose solutions for that. The opportunity is that every day in our life, maybe I'm talking about myself or every one of us, we are daily accustomed with the e-commerce businesses, B2B or B2C, for recommended services, maybe for a user item or a user service or any particular product. So we definitely depend highly on genuine and trustworthy recommendations. And one of the biggest threats is that specifically in the pandemic era, the demand for cloud services have accelerated a lot. There has been a huge leap in due course of time. So managing the ever increasing data, managing the big data is one of the biggest challenge. And apart from that, the basic challenges with recommended systems is cloud. This is cold start problem when we have less amount of data available, and the data sparsity problem when we have limited number of similar users available. So in my conclusion, I would definitely like to emphasize that recommendation system models which are available, I have given a categorization for them in my previous slide, that is existing there. But a comparative analysis definitely shows that there is a need for amalgamation of each one of them to sort of provide better recommendation and better trust for the cloud service providers in the upcoming time, because we have seen a lot of data breaches are there, and even popular e-commerce websites like Amazon also have suffered from these data breaches. So security of data, data integrity, and the trust of the customer will be maintained and sustained on the service providers only when we are able to provide authentic recommendations. In my future work, I definitely propose to develop a trust-based rating recommendation system, not only for predicting appropriate suitable ratings, but also for identifying malicious users or misfeasors whose revocation from the access control list is definitely the need of the hour. And apart from that, this work of mine will also be a solution, will also propose solutions for the existing cold start and data sparsity problem which is prevalent in recommender systems. So thank you all for your attention. These are the references. If I can have any questions.
Dear researcher, your presentation was really good, and I just have some questions with regards to your trust recommendation systems. Could you please explain a bit about what you are going to propose for the future?
Yes, sir. So for the future, what I'm going to do is that, let me just, okay. So is this slide visible?
Yes, 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 it is quite visible.
All right. Now, if I take a threshold value delta, and for example, if I have on the scale of 5, if I want to rate a service X, and if there are, for example, 5 users, right?
Okay.
Now, if I have a value, my threshold value is greater than or equal to 2.5, that means if for a service X, out of 5 users, majority of users are recommending that particular service, recommending, giving positive feedback for that particular service, I can directly recommend that service. If it is not there, if it is not greater than or equal to 2.5, then I need to check for the similarity index. So I'm proposing to use Pearson's correlation coefficient formula to find out the similarity. And apart from that, what I'll be doing, I'll be building a trust network. For example, if I have 5 users, so I'll be preparing a directed graph using the graph-based recommendation system. So U1, U2, and maybe U7 and U6. So I'm also planning to use the cosine similarity in order to identify the similarity. For example, if we all know that cos 90 is 0. So if I have the similarity index between two users does not exist, that means if U3 is not there, if I have a directed list from U1 to U7, it is not necessary that I have a directed edge from U1 to U3. So only trusted network will be built between those users whose services, who have got number 1A, the recommendations from the existing service, because at a particular point of time, not every user is active, right? Sometimes when we face data sparsity problem, that is because maybe a particular user has logged into the system, but he or she has rated only a limited amount of services. So in that case, what happens? That similarity index is not counted into the database. So if I select at a particular point of time 2 users, then I rate them as x1 and x2, and I compute the Pearson's coefficient correlation that gives me the similarity between 2 users. And accordingly, same matrix is same configuration is done between all the existing users, and I prepare a trusted graph, and based on that similarity, I perform the computation. Now this particular step is phase number 2, because if I directly get sufficient recommendations with respect to my threshold value, then I can directly recommend the service. B, if I do not have sufficient amount of recommendations, then I go for computation of the similarity. As of now, I've thought with this particular process because I'm already working on this, but once I'm completed with this particular work, I'll definitely eventually, even if by that time we have a conference like this, or then I'll definitely try to submit that particular work for service recommendation as well.
So do we have any simulation results that you can show to us?
So actually this study of my simulation results for that particular work which I'm going to propose in future?
No, what you have presented right now.
Yes, sir. Actually, in this particular work, I have performed a systematic review. So I have performed a SWOT analysis, the strength and weakness analysis.
Okay.
And I'm working on proposing the trust. I'm working on integration of trust and recommendation systems.
So we do not have any results, yes?
So results I have in terms of the literature survey that I have done.
No,
In terms of
whenever
the
you take
literature
in the case of
survey.
any paper, it should have some statistics data, what you infer from it. There should be something. I couldn't find
Yes,
that.
yes, I can, maybe it's not included in the slide. Just give me a second. I'll share that particular paper. Then in that I have the tabular representation that what are the contributions. Can I share that?
Okay, if you have real results, do share me.
Yes, sir. Yes, sir. On your mail?
No, you can just show me in
Okay.
the screen.
Okay. Okay, sir. Just a second. I'll just open that. So is my slide visible?
No, ma'am.
No, not yet, ma'am.
Okay. Just a second.
We
All
are
right.
seeing
So
some
this is.
equations, yes.
Oh,
Yeah, so this is what I was talking about, that I'm talking about the similarity between the two users. So I'll be using cosine similarity function to identify the similarity between two users, UI and UJ. And the similarity actually is computed using the Pearson's coefficient correlation formula, and wherein we compute a user trust network set between two users, and eventually a graph is being prepared. So the predicted rating is being computed and a cumulative trust. So what I'm trying to say is that when we have a particular similarity for that particular user, if it is not zero, if the like cos 90 eventually comes out to be zero. So if we have, because I'm using cosine similarity, so if we have a value for particular user combination, then we go for that particular trusted network set. Apart from that, if we do not have a value over there, then we don't skip to this particular similarity index value. If it is not there, if it is there, any value exists, then we move to step number 2, and then eventually we compute the cumulative trust and the rating prediction is being done. And these rating predictions help in recommendation that whether this service should be recommended or it should not be recommended. And for that recommendation, I've considered a threshold value delta. And for that delta, on the scale of any particular value we can take, maybe on the scale of 5, I can select that delta should be greater than or equal to 2.5 for services to be recommended, or maybe we can take a decision eventually that we do not want to recommend that service. So all these things are in sequence with one another.
Okay, ma'am. Thank you.
Okay, thank you, sir.
thank you so much, ma'am. Thank you so much, sir. We'll move ahead to the next paper ID 434, titled as Wearable Smart Jacket for Coal Miners Using IoT, and it will be presented by Mr. T. Ananth Kumar.
Yeah, yes, ma'am. Yeah. I could be able to share screen.
Yes, sir, you can share your screen.
Yeah, yes, ma'am.
Ma'am, I wanted to ask something, that if I'm done with my presentation, can I leave the meeting?
Yes, you can leave the meeting.
Okay, thank you so much, ma'am. Thank you.
Yeah, good morning, ma'am. My screen is visible now.
Not to me.
No,
Can
sir,
someone
it is
else
not visible.
confirm the same?
Okay, I have already shared the screen.
You can do it once again, sir.
So this is an introduction. So we have used IoT sensors and enablers to monitor the patient's condition and so not only patient, the worker's condition in real time by connecting the IoT intelligent things such as temperature sensors, heartbeat sensors such as LM335, IR sensors, and infusion forms and alternative sensors in the network. So data from these sensors is received by the microcontroller. We are used to microcontroller ESP8266. So this is a low cost controller which consists of Wi-Fi also. So normally we have first we have used trying an Arduino board, and that board don't have Wi-Fi access. So we have used ESP board. This is a low cost board, and we have introduced a mobile application which generates an alert message based on data from the microcontroller. So it has been uploaded to the cloud platform. So that is a free cloud only. And using this app architecture, so the manual work is very much reduced, and we can able to allow the data retrieval at any time. So this work we can able to emergency do any surgery, do is there any action able to access, we can able to track the all workers anytime. So this is a proposed model of a system. So we have used So we have good heart rate sensor, then LM35 sensor, that is a temperature sensor, and IR sensor for detecting the distance between the other workers. Then we have power, this is the Arduino controller for years. Then later we use that ESP model. Then we have in Arduino controller we have connected with Wi-Fi additional device. Then later we have used ESP model only. Then relay driver, infusion pump. So finally we have connected the device into IoT device. So the IoT means that it is connected to cloud. So this model consists of ESP8266. So it is capable of very low cost device, and it is a size of 64 KB in size, and so it have SPI interfaces. So we have AX interface and ISO interface. So this one have a SPI interface for low cost memory only. So this proposed system have the heartbeat sensors for measuring the heart rate by employing the photosynthesis principle as basics. So here we can able to this do the transmission through the vascular region of the
Hello,
body,
sir.
such as earbuds, light emission from the light emitting device.
Could you
Then
please
we
ask
are used LM35 temperature sensor. This is used to determine the temperature in pinpoint accuracy. It was a very low cost sensor. So here we are able to classify photos into two categories, such as reflection, centigrade.
No. I am in the conference.
So when the temperature of ice core is the 1 degree Celsius, the output power of the chip increases by 10 millivolt. So the small minor device, the LM35 comparator circuit diagram, is differential amplifier also. So here the pin 3 serves the input and output of the output is non-intuitive using this device. So when you have using this device, the output will be very accurate and the data will be transferred in the very fast access. So here we are using infusion pump also as a medical device. So that infusion pump is that will assist the patients at national call workers to receiving fluids in their from their bodies in places. So such as nutrients, then water levels, then there are a variety of methods for admission in medication also. So here we can able to possible to deliver the fluids in minimum volumes at the program rates. So this is a temperature sensor circuit. So this is simply means of infusion pumps. So comparatively, this infusion pumps perform very well. So this is a output of our block diagram. There is this proposed architecture. Here we are having the diodes. Then this is the ESP state. This is ESP state. So here we are having the additional one. Then temperature sensor. Then heart rate sensor. Then everything will be connected to this Wi-Fi model. Then LED device, LCD device. So these devices transmitted data, that acute data such as heart rate,
Hello, sir.
then temperatures, then other data to the cloud directly. So this one which showed whether the temperature is active, it will show the temperature is normal. So we have using AI based device. So we have set the parameters and train the device using some parameters. So if the temperature is normal, it will show the below the level means it will show the data as temperature is normal. So in conclusion, yeah, wearable technology will allow us to monitor the human activity. So right now we are working on wearable sensor, that is we are going to fabricate the device in the dress. So first we have this is a prototype only. So after this we are going to fabricate the device in the dress also. So that it will be useful for us. So using the product and the minus the cold minus pulse rate, current temperature, humidity, exact propagation, and global position can be also tracked. So this will be very useful for the mine workers. So can they be safely be the mine. So in future, what we'll be going to fabricate the device. So these are references.
Okay, Anand Kumar, thank you for your presentation. Just one question for you. Like, what is your dedication or maybe application of your IC741 with regards to this project?
IC software is an operation amplifier. So we are using this for improving the efficiency of the circuits. Okay, so this is a differential amplifier. So using this, we can able to reduce the power distribution also. So that will be very useful in cloud, in mines. So which you can able to reduce the power of the circuit, so that it can the proposed device can be work for a long life.
Okay. Okay, ma'am. Can we move on to the next presentation?
Yeah, we will now move ahead to the next presentation for ID 435, green cloud-based efficient security mechanism for Aadhaar voting system. And who will present for paper ID 435? Anyone? Please raise your hand here.
435 is
yes,
the
ma'am.
same, ma'am.
I will proceed it, ma'am. Yeah.
Okay, sir. So you can go ahead with the presentation for 435. And you will present 396 and 417. Okay,
No,
396 as well?
Yes, ma'am. I will present 396 as well.
Okay, you can go ahead with both the presentations. I'll just inform the audience that Mr. T. Ananth Kumar will present the paper ID titled as just mentioned, and also paper ID 396 titled as Artificial Intelligence Based Visual Aid with Live Tracking of Visually Impaired People. So these two papers will be presented by him. So you can go ahead with your presentations.
Yeah, thank you. So good morning, everyone. So the paper ID is 435. The topic is Green Cloud-Based Efficient Security Mechanism for Aadhaar Voting System. So I am Dr. Ananth Kumar. So this is the outline of my presentation. So just a minute. Yeah. So first I started the abstract, then introduction. So then proposed model, the block diagram, then results and conclusion. So first I started this. So previously, we have the voting model such as the manual voting process. So in that, the major difference is anyone can fake it. So using the false identity card, duplicate identity cards. Then, so we are going to propose a Aadhaar-based EU IoT voting system. So in elections or choosing in forming the governments in a country like India. So the value of recommended votes flung by people. So at present, so EVM is used which has certain disadvantages. To securities. The main goal of the work is to design a reliable voting machine, so which consists of which is linked to the Aadhaar. So with the improved security and ease of accessibility. So here we have used fingerprint sensors, microcontrollers, LCD display, and globes and GSM models. So entire process will take the secured green cloud. So here we are using cloud services to employ the different technology principles to allow greater use and performance than conventional computing. So cloud is used to store that you can able to store the data directly to the cloud server. So here the cloud is delivered dynamically and viewed as single service level arrangements considered on the invention among the provider and customers. So we are using green cloud computing. This is a technology that leads to design, manufacture, and use digital devices. This system can conserve very low energy with decreasing operating costs. The green computing, cloud computing is idea on the added value of green computing. So green cloud provides an energy conscious cloud computing data hub similar. So cloud computing renders the railroad services to users focus on utilities. So it contributes to sudden use of energy and increased consumption on fuel gas. The cloud green cloud is needed that way that saves electricity. So but also reduces the maintenance cost. So if you are having the server in the space means it will be we need more servers. So we are going to use a single cloud server. So here India has a absolute voting system. So many EVMs are already produced in countries. They have started using like this. So EVMs in the India have no mechanism to verify their identity in advance for casting votes that enable fact voters to cast multiples. So these new features directly affect the budgeting of the IT, that's information technology, and affect predictable structures of security, confidence, and privacy. So previously, the papers are already there. They are mentioned they have also tried that which we can able to increase the security with double verification, then improving the productive nature, and then they use mobile application for also that they have many drawbacks, and as well as they tried some unauthorized presence, they reduced to that. Then they try to implement the device, but the cost will be very high. They showed they're offering the scheme for preventing the methods of bullying. So we have implemented a new proposed system for that. So yeah, to ensure the power management, we have used intelligent resource allocation and paving way for devices to recycling the system also. So the key concept behind the proposal is to provide the quick access along with authentication protection. So this proposed system consists of fingerprint sensor, which is in authentication for purpose, and authorizing that means that other resources. Then we have microcontroller, so processing the data, and the GSM device for sending the SMS also for security. And we have used IBM cloud and using Glowfish algorithm, and we have added an LCD for displaying the cost of vote. these votes will be stored in the green computing based system. This is the proposed model block diagram. So the major key concept began the proposed is to provide quick access with authentication protection. So this proposed system consists of fingerprint sensor. Okay, so we have used fingerprint sensor, that is a device meant for getting the input in the form of fingerprint, and which will be converted into this one. This will be converted into digital data. Then the main advantage using fingerprint is unique for everyone, so we can able to control access other data. So as of now we have developed a model only, that's a prototype. So in later we can able to connect with the other device, other data. So that's the fingerprint is the easiest way of providing authentication. So we use GT511C3 fingerprint model for this system. It's a 4-way pin with the embedded model, and we have used the Atmega microcontroller. For us, it's a high-speed controller with the 16 megahertz processor. So data retention capacity is 25 degree Celsius. Then we used GSM model also. GSM model has that there's a global system for mobile communication for sending a notification message to the voter. So whether the voting is done or not. So that's a double security likewise. Then we use 2x16 LCD for displaying the cast of it. So we have implemented a prototype. So the low cost model. So initially the other details are for sample, we have chosen some other details for the distance contains the cloud database. So in the separate database, candidates list is stored with respect to the location and polling booths. So these are accessed during the time of voting for the identification of the voter and respective polling booth. So during voting, the fingerprint of the voter is used for the authentication, and that will be compared to the other database, and it will be help in identifying the corresponding polling booth of the voter as well as the voter's address in the database. So after identification, the candidates will candidates list will open for the voters constituency. So once the vote is cast, the vote will be shared and stored in the cloud without the identity of the voter. So, but for the respective candidate, the voter will be noted via the text message, that is using the GSM message. So these are steps in that. So first, it's an expense setup with the Atmega 328 board. So that is associated with the fingerprint sensor. So device is prepared for finger scanning. So when it is correctly placed, it will check the authorization. So when the approved voter, that is if the fingerprint matches the details in the other database means, an individual voter has not placed voter means, the system will display the name and list of candidates of the particular area. So if the vote has been cast successfully, the machine will send the message to acknowledgements to the individual voter in a mobile. So that is if you have voted successfully. So if the voter which already speaks the vote means, the machine refuses and reveals the vote has been already cast. So eventually, if the votes flung using blowfish encryption, the votes are encrypted to secure the data. So this is our experimental setup. This is Atmega processor, that is Atmega 828 board. Then this is a Wi-Fi model, that is GSM model to send it. There is a LCD device. Then there is a fingerprint sensor. Then the power display on. So we can, if the voter votes means, we will receive the message that you have voted successfully like that. So if the voter tries voting against means, they will be noted like this. The user do already voted like that. So conclusion. So we have used IBM Cloud as application that facilitates limitless amount of storage, and the data is being encrypted using blowfish algorithms, then stored in the IBM Cloud. So the existing voting system practice contains checking for the voter details manually in the polling booth on the day of election and allowing the voter to cast the vote. So this system is serious, that is requires heavy manpower. So we have the proposed system has many advantages such as authentication voting procedure. So we don't need any voter ID, and we have inbuilt franchise scrutiny. So we have also immediately you can declare the results also. And we for second authorization we are sending the messages to voters also, so that we can able to reduce manual work, and the cost will be also reduced. So this one will be very useful for that. These are reference of our paper. Thank you.
Okay, Anand Kumar, thank you for your presentation. I would be really happy if this system really comes into power. And can you
So,
please discuss the shortcomings of your system if it comes into effect?
so actually, previously they have anyone can vote like the duplicate votes, and so now also they are refusing to activate this, because if they use mean they cannot able to false voting. They will do false voting, so they are not supporting that projects also.
Okay, could you please discuss the importance of green cloud computing with the scenario which we are experiencing right now?
Actually, cloud computing refers to the basic infrastructure. So, for expanding in the form of carrier provision, so green computing means we are going to store the data in the cloud, as well as we are using blowfish algorithm for securing the data. And so the major advantage, there is ability to measure the store data remotely, and we can able to store results in the complex environments. The main thing is we can able to reduce the power of cost of servers. We are if we are having servers in each polling system, it will cost more. So we are having green cloud server, so it will be able to reduce the power consumption, as well as that storage ability also. Shall I move to the next presentation, sir? Ma'am?
Can we move to the next
Yes, sure. Go
presentation if
ahead
we
with
don't
the
have
paper.
any queries from everybody?
Yes, so you can move ahead to paper 396, ID 396.
Yeah, okay, ma'am. Okay, thank you. So, this paper ID is 396. The title is Artificial Intelligence Based Visual Aid with the Live Tracking of Visual Impaired People. So, I am Dr. Ananth. This is the outline of my presentation. So, first we'll start with the abstract, introduction, then proposed system, then the components, final results, and conclusion. So, blind people cannot do things like navigation by their own, recognize objects or other objects, because they cannot see what is around them. So, in the future, they need their new device for completely blind people. So, as a result, we have developed a new device using Raspberry Pi, so which is the cheapest one, and which again able to artificially coding that device, because so this is a AI based device. So for training and that training, we need some Python coding. So here people use ultrasonic technology and the camera to figure out, so what are the things are far away, then what are things are before them. So this system subject avoidance computation includes camera and other sensors, so we can able to identify the things what are things before us. So the products will be lightweight and it's easy to move, so which is making them to easy to move. So normally regular eyeglasses can be used as a base for these glasses, so that you do not have to spend extra money or make things more complicated. So using this idea to make eye glasses, there is a wearable glasses, so it's a more complicated one. So the price of complex items would not be changed way out this. So normally people use advanced technologies. So introduction that. So we are using embedded operating system for community device. So in order to we need C++ programming and Python coding for that. So visual impairment is a inability or inability to recognize what you are looking at. So which makes so visual impairment can affect anyone at any age. So in 90% of cases, human decisions are transferred from the eyes and to the brain for processing and making good decisions. So what is before us behind us. So disabled status will be granted to people when we are unable to see what is behind us or before us. So previously these people rely on traditional walking sticks. So later they started with very normal ultrasonic sensor to detect the models. So now we are going to develop a device such as AI based device. So we can able to find the objects, what are objects before us also. So this is IoT based device, is outfitted with sensor, actuators, processors, and other things also. During this process, the design and development hardware and web based are carried out, APIs are carried out, and connect technologies are with a wide range of plasmas and networks with the essence of communication on a global scale through digital communication. So this is a proposed model. So we have this Raspberry Pi B, so which is around, this costs around for $5,000, and we have uses ultrasonic sensor. Then we have used Pi camera for pre-processing stuff for training the data, and from that only we are going to process video frame processing, then audio feedback to. So here the Pi camera is connected to the Raspberry Pi where pre-process will be taken out, and the ultrasonic sensor is connected to measure and notify the distance. The Raspberry Pi's mode of communication with the is through Ethernet cable only. So in order to connect to the internet, there has been internet control the home router. So that is a proposed prototype only. So we are in process of reducing the cost. We have used the Ethernet only. So this is acknowledged as a general purpose pins in the Raspberry Pi. So normally in Arduino we have 28 pins. Here we have 36 pins. And this board have 5 MB pin memory. So this processing units consists of a ARM11 processor. This processor has been integrated with the mobile phone. So using this proposed model, so you could connect it to the temperature sensor and use it to transmit the digital data. So it is necessary to use a Zigbee to another devices that communicate wirelessly using Zigbee model. So a small switch on the cylinder is connected to the cable that receives power from the power source. So it is allowing you to use it as a power source. So this connector's primary function is to connect an external power source as simple as possible. So it is possible to use a universal asynchronous receiver transducer as both input and output. So here this can accomplish many different things, including transferring serial data bus and changing depending cores. And so the connection to the Raspberry Pi can be made using a HDMI cable depending on the board model. The connection of wide range LCD and high definition television monitors is made possible by using the HDMI male cable and low cost adapter. So we are using other versions also. The sound and video are connectors transmitted through HDMI when the Raspberry Pi is connected to the television. So we can able to directly monitor it. However, the board does not consider in the HDMI port the composite video, that is the video output from that, it cannot be used as a controller. So we need to add some RCA kits. So the final steps is to connect the Raspberry Pi to the internet. So Raspberry Pi board comes with an SD card. This means there is a, when we add a SD card, this is a storage device, then it will send the data to the system. We are using this. So first we are going to train the model with some data sets. So what are the things available in front of us? So we have used the data sets from Kaggle website. So download the data and train the models. After that we are tested devices. So this is the performance of a single registration. First I'll show the device. So this is accuracy of that. First we have trained the devices. So first we have the passions and so we have used Kaggle data sets. So this is the output stuff of the virtual license node. So it will has an accuracy of 97% for mobile phones and for mouse. And we have ultrasonic sensor for detecting the devices. So it will sense the data and detect distance between the models and that. So such as 8.4, 9 like this. So using the visual aid present on AI basement, both films reported it is a slightly faster at navigating the traditional white lane. So beside it predicts object with an accuracy of approximately 98% and provides precise measurement assistant people in avoiding obstructions and ensuring that the location is continuously monitored as well as communicated to the guardian. So in part to the high frequency, so this system can accurately identify single items such as nearly 100% and zero failure cases. We are improving the models so that we are adding the more data sets. So sometimes we have to add the data sets also. So these figures shows the output snapshot, so which will subject along the distance. So conclusion: blind people have a more challenging time performing tasks like unaided navigations, object recognition, and obstacle avoidance because they cannot see their subjects. So this proposed system, there's a low-cost system, will provide the information regarding our cutting-edge visual aid system for those who are deaf and visually impaired. So the prototype capabilities of frameworks were demonstrated with the essence of Raspberry Pi Model B. So the amount will be very low than the camera, Raspberry Pi camera sensors. So this is a total cost we have only spent $6,000 for the total model. Additionally, we have GPS from other projects. So if we do not choose to bring this product to market, it will likely do so. So now, unless instead of using standard eyeglasses, we can able to use these glasses for blind persons. So it will be very useful for them. So this is a reference of our project. Thank you.
Okay, Ananth Kumar, thank you for your presentation. Could you please discuss the importance of XB connector in your Raspberry Pi device?
Which one, sir?
XB connector.
XP connectors. Actually, this is a connector which is used for instance. So normally we use connectors means normal models only. So here we use a XP connector, that is a Zigbee model. So we can able to transfer the data instead of networks, that is a wired network. We use Zigbee connector so that no one can track the frequency. So we can, if we set the baud rate as 9,600 or 11,200 means that data will be transferred only to the Zigbee receivers. So there will be no intrusion begin that. So for securing the data for that is for sending the data wirelessly, we use Zigbee connectors.
Thank you so much, sir.
Shall I
Thank you for
leave
the
now?
presentation, sir.
Yeah, thank you, ma'am. Thank you.